Hey everyone, and welcome back to the channel. In today's video, we're going to be working through compound increasing annuities with a focus on forecasting the cash flows clearly using Excel. The goal here is not just to get an answer, but to see how each payment grows over time and how compounding fits into the structure. I'll walk you through how to set it up step by step and show you how it's done. Let's get started. So for question 1, we have annual payments for 12 years. With the first payment in year 0 is 2,000. Payments increase by 5% for the first 6 years, then payments increase by 3% for the next 6 years, and with an interest rate of 9% per annum, and it says find the present value of the annuity. So the first thing I'm going to do is I'm going to have my column with time in years, since our payments are yearly, beginning at year 0, move to year 1, year 2, year 3. And then all I do is I highlight and I drop all the way to year 12. You see, Excel has this powerful way of recognizing sequences. All you need to do is just highlight all the cells and then you just drag and drop. And then afterwards, I'm going to have another column for my payments. You see, since my payments are going to be yearly. And I know that my first payment is going to be 2,000 beginning at year 0. And then afterwards, we need to ensure that we incorporate our compound increases. So for this column, I'm just going to have a column for compound increases. You see, I'm going to abbreviate increase for INCR. And you know that for year 0, there's no increase, so we just have 1, you see. But from year 1 onwards, we do have an increment of 5% per annum. So I'm going to say equals to bracket 1 plus my 5%. And make sure you cell fix as you reference. You just click F4 at the top of your keyboard so that whether you drag or drop left, right, up or down, it stays at 5%. And I'm going to press enter. And then to make sure that stays as a decimal or as a number, I'm going to drag for 6 cells because we need to ensure that it covers the first 6 years. So this is cell 1, 2, 3, 4, 5, and 6. That's our 5% per annum. Afterwards, we need to also ensure that we incorporate the 3% per annum. So same strategy of 1 plus 3%, cell reference, F4 to fix, close bracket, enter. And of course, I'm just going to change it to a number. It's up to you. You can leave it as a percentage or leave it as a number. It's up to you. And then I'm going to drag all the way down to 12. To ensure that it's for 6 years, I count 1, 2, 3, 4, 5, and 6. You see, so that's my compound increments. And now after that, we need to ensure that our payments are compounded correctly. So since I know that my first payment is 2,000 in year 0, I know that in year 1, it's simply my previous amount, right? The amount I received last year multiplied by the compound increment for the current year, which in this case is just 1 plus 5%. And I press enter, you see. And then the beauty about Excel is that once you have your specific formula, all you need to do is just drag all the way to the bottom, you see. So I'm going to click, and I'm going to drag all the way to the bottom, and it carries the formula for me, you see. So these are my incremented payments. And if you're to just tap and see what the formula is, you can see over here that the payment in year 10 is just the payment in year 9 multiplied the current year's compound increment, you see. So that's the beauty of sort of separating everything for yourself, your payments and then your compound increments, to ensure that you don't leave anything behind. And now after that, we need to have a column for our discount factor, right, to ensure that we discount each payment properly. And in this case, we know that our interest rate is just 9% per annum, right? I'm doing this for the sake of cell referencing. Interest rate, you see, like that. And then once I do that, I'm just going to say this is equal to 1 plus my interest rate, which is 9%, cell reference by F4 fixing. And then I'm going to raise that to the power of negative the current year, which in this case is just 0. I'm going to press enter. And then when I drag all the way to the bottom, I know that everything is going to be done accordingly, right? So that these are my discount factors, right? As you can see with this cell, it's just 1 plus 9% to the power of negative 12. And then after that, I need to make sure that I ensure that my cash flows are discounted. So I'm going to say discounted cash flows, right? I'll just use CF for cash flows. And I'm going to say this is equal to my discount factor multiplied by my payment for the current year, you see. And then I just drag all the way down to the bottom. So this is basically the present value of my cash flows, you see. And then of course afterwards, in order to find the total present value, I'm just going to have a column for present value, or PV for short, and I'm going to find the sum of all my discounted cash flows, and I should get a present value of this amount, 20,451.36 That is how you find the present value of the annuity. And of course, there are different ways of solving this. This is just one way I find that works for me. Now on to question 2. We have an investor deposits money at the end of each year for 10 years. First deposit at the end of year 1, not year 0 this time, is 3,000. Payments increase at a constant rate of G% each year. Interest rate is 8% per annum, and the present value of the annuity is known to be 45,000. Find the growth rate G%. Now notice this one is slightly different. Instead of the normal linear path of finding the present value of the annuity, now I have to work backwards. Now we know the present value. Now, how are we going to calculate G%? And immediately what comes to my mind is use goal seek, right? So what we're going to do is that we're going to set everything up as usual, you see. So this time we actually have to guess our growth rate. It doesn't necessarily have to be correct. We just have to be able to use it, you see. So in this case, I'm going to have my growth rate, right? And I'm just going to say, for an example, it's going to be 10% per annum, right? And then I have my interest rate, right? My interest rate, which we know is 8%, you see. And now I'm going to start off with my columns. My first column is going to be time in years, since our payments are yearly. Start from year 0, move to year 1, year 2, year 3. All we have to do is highlight, because by now Excel has understood the pattern, and you just drag all the way to 10 years. After that, we're going to have our payments, you see, which we know that the first payment at year 0 is actually 0, right? Because the first deposit is at the end of year 1. So just make sure that that doesn't catch you. And then first payment at year 1 is 3,000. And then in order for us to find the other payments, we need to use our compound increases, right? So I'm going to have my compound increases, right? At least now it's only 1%. We don't have 2, right? So after having our column for compound increments, we know that year 0, nothing happens. So it's just 1. Year 1, also nothing happens, because we know that the payment is 3,000. However, we don't know what the payment is for year 2, year 3, and onwards. So this is where our compound increment comes in. We're going to say equals to 1 plus our guess growth rate, which is 10%. Don't forget to fix by clicking F4 and then enter. And then I'm just going to leave this as a decimal, right? And then all I do is that I just highlight, or rather I click the cell and I drop all the way to 10, you see. Since we know that it's just at a constant rate of 10% each year. So then my payments will be the previous payment, right? The payment from the previous year multiplied by the current compound increment for the year. I press enter, and then I just drag the formula all the way to the bottom, you see. So we know that the payment at year 10 is just the payment at year 9 multiplied by the current year growth rate, which is just 10%, you see. Now after that, we're going to have our discount factor, right? Discount factor, of which we know uses our interest rate of 8%. So I'll say equals to 1 plus 8% fix using F4 to the power of the negative year, which in this case is just year 0. Press enter, and then I drag all the way to the bottom. And to make sure it all makes sense, we know that the discount factor at year 10 is just 1 plus 8% to the power of negative 10. You see, as you can see with the highlighted cells. And then after our discount factor, we need to discount our cash flows. So I'm going to say discounted cash flows, CFS for short. And I'm going to have my discount factor multiplied by the payment. I'm going to press enter and I'm going to drag everything down to the bottom. And this is what we have, right? And of course, to tie everything off, I'm going to say present value, right? And then I'm going to simply find the sum of the present value of each cash flow. And voila, that is my present value. But notice that I'm not done yet, right? Because firstly, we guessed our growth rate and the present value of the annuity is supposed to be 45,000. You see, now that we know this, this is where GoalSeek comes in. All you do is simply go to data, right? And then go to what if analysis over here and you tap on GoalSeek. So now with GoalSeek, all we do is that we set our SAL, in this case, our present value SAL, and we want to set it to the value of 45,000, you see, because we want the present value to be actually equal to 45,000. And then how are we going to do it? We're going to do it by changing the growth rate, you see. That's the growth rate we guessed, and that's the growth rate that we want. And then all we do is we press OK. After GoalSeek does its iterations, we know that, okay, fine. A growth rate of approximately, when I make it more accurate, we should get a growth rate of approximately 19.16778% will actually give you your desired present value of the annuity of 45,000 Rand, you see, or dollars or pounds, whichever currency you use, you see. So that's the power of using GoalSeek. And also notice, guys, that when you do this GoalSeek strategy, it's always important to make sure that whatever value you've guessed is actually embedded inside your calculations or embedded inside your structure, you see. Hence why I put everything separate, and having the compound increase column, we have 1 plus our 19%. If, for an example, I had done this equals to 1 plus 19%, if I had manually typed it in, it wouldn't have worked, you see, because there's no cell reference that we're actually changing, you see. So this is why it's so important to make sure that you separate the two and always ensure that your growth rate and your interest rates are referenced correctly. And that's it. That's what we have for compound increasing annuities. The key thing to remember is how important it is to separate your columns properly so you can clearly see the structure of each payment, the growth, and the compounding over time. Once the layout is clear, the math becomes much more manageable. If this helped, please like the video, subscribe, and hit the notification bell to stay updated. If you have any questions or alternative approaches, feel free to leave them in the comment section below. Shout out to IJ Beats for the instrumental used in this collaboration. And I'll see you in the next video with me, Tutor Next. Simplifying success, one question at a time.